But you don't, yep. 1 second, sorry about this one, I think. I wasn't able to see it. Yeah. Please let me know if it is not visible, because it's a really big, small screen. Hello, everyone. I'm Sinan Kozak. I'm coming from Berlin. And today, I would like to speak about doing nothing, because I'm a lazy guy, and I would like to avoid doing something as much as I can. It could be moving one stuff to do some other place. It could be executing a code or building my project. Because why not? Why should I wait for building the same thing over and over again? I'm actually curious, are you a lazy person? Can you identify yourself as a lazy? That's the spirit, because I also expect any lazy person to not raise their hand as well. So if you're a really lazy person, you know it, and you don't want to share, great. And if you're also impatient like me, you don't like to wait during the builds and just would like to focus on what you can produce for your company or yourself or whatever you like to do, this talk might help you. And we all have similar pains, right? Besides the neck and back pain that caused by sitting all day, we also have a build time pain that is an statico in the Android community, and we have to live with it. But is that the true statico that we need to accept? Because I know there are some companies are not using or putting efforts to improve the developer experience, but I was lucky and fortunate enough to work in a couple of environments. They were improving the developer experience over hiring someone new. And that resulted having faster build times, faster delivery times, and happier developer rather than constantly complaining about how bad the Android compile time is. But what is the ideal build time? Does anyone have less than 1 minute build time here? 1, 2, 3. Does anyone have less than 15 seconds or 10 seconds in average for all your local builds? Or a couple of minutes for your CI builds? One lucky. And I hope I will convince the rest of you to have similar improvements and enjoy your life, and rather than waiting without doing anything in front of the screen. But unfortunately, our applications are using Java and compile, if not Flutter. And we have to compile those languages before running on the runtime. And we need to compile them again. And again, when we change something, guess what? We need to compile them again. And before deploying it, we need to package them. And we have lots of resources that we need to package, like strings, XMLs, drawables, source code, GNIs, and a bunch of other things that Android requires to run on the runtime. And how we can avoid this one, so we can use cache. And then where we can put our a cache system in the lifecycle of our build. When we would like to build something, we'd get the code from the source code. Repository. It could be GitHub, GitLab, or anything else. But when we get it, we need to compile it. But before even compiling it, I'm pretty sure that there isn't any repository or project without any dependency. So first thing Gradle is going to do, or like a compiler will do, is downloading the dependencies and making sure that we have all the necessary dependencies before even starting compiling our own code. And the other one is like compiling without any local build output or cache. This will be completely fresh compile, and we need an outcome so we can run our application. And when we change something, and if we don't have any cache, but let's say we have compile output and everything, but our compiler doesn't know or configure how to use this one, we need to compile everything again. And if we don't have like the cache for the dependency, we definitely need to download the cache. But luckily, Gradle comes with already the cache mechanism for dependencies, which is already enabled. If you don't change your input, which is your library version, Gradle is not going to try to download it again, because There's a library which is already downloaded, which has the same hash before, and your input is same. All good. For the same input, there will be same output, so it's already cached. But what other kind of things Gradle task can process output for us? Let's say we have a Gradle task compilation. If we don't have any resources in the module or a project, Gradle task will say that, hey, there is no source. I cannot do anything, so I'm skipping this one. But let's say we have a source code, then Gradle will say, I compiled everything or executed everything from the source because I don't have any cache, I don't have any output, so everything needs to be compiled and it's coming from the source. Another option that you might see already in your logs is up to date. If your files didn't even change since the last compile, it doesn't even matter you have cache or not. Gradle is clever enough to say that, hey, files are the same since I compiled everything, and I don't need to compile again. But this is the part where Gradle does. And there's also another part of cache layer which compiler can do, which is incremental build. Compiler can look at the incremental outcome and output of they produced before and try to understand what they need to change rather than compiling everything. And besides that, if your compiler or the task doesn't have incremental support, Gradle can check, is this task executed before with the same input? So Gradle can use the same output without doing any execution or computation and just purely relying on the previous execution and the output. And the best of all, what we can do, what we can take one step further is sharing our outputs for the for the same inputs of those Gradle tasks. That will be the holy grail. Imagine that you wake up or you came from the vacation, and the first Monday, we open your computer, pull everything from the develop, and everything just compiles without any CPU execution, without compiling locally, but just getting the outcome from the remote server and making sure that you're not wasting your time while waiting to compile someone else's code. When you develop something on your local device, you definitely need to compile your own code. But what is the cache? Cache might come from different layer. We might have a software cache, we might have a hardware cache, and if you think about CPUs, they have different layer of cache. Some of them is like really small but super fast. Some of them are like much big, a little bit bigger, like in the megabyte size, but slower than the L1 cache, but faster than the RAM. So even the hardware level, our computers and devices are trying to optimize cache as much as they can to reduce the amount of computation or I/O operation they would like to use. Why? Because it's expensive and it's slow. And they also like to lazy. So what kind of caches we have for our development environment? The most famous one, probably the Android Studio cache and the infamous invalidate cache button and the restart. And I already mentioned that we are using the cache dependencies because we also don't want to download them again. Android build pipeline have different layer caches. It could be like they have cache for packaging system. They have cache for shrinking the XMLs or creating PNGs out of our XMLs. There are different layers they try to improve, but not everything is related to Gradle, and sometimes they have their own caching system. The one thing that we can, one new feature that is new in the community is the Gradle configuration cache. Gradle needs to configure all of the tasks before executing any of the tasks or compiling or doing anything else. Why? Because those execution time, in that execution time, we are setting our input to the Gradle inputs. It could be the path of the source file, it could be the name of the file that's going to be generated, anything is possible, but good thing is that Gradle worked really hard on this one, and now we have this configuration cache. And the interesting thing, if you don't enable this configuration cache, we are paying this time or in computation for every build we have. Even if we run Gradle help, even if we run Gradle clean, there will be always Gradle configuration because Gradle needs to know what needs to happen. But if you can enable the Gradle configuration cache, you can avoid this fixed time for all of your builds. And the last time in my last company, when we enabled it, we simply get rid of the 30-second configuration time for most of incremental builds that we have. Was a huge benefit of having it. But that's a Gradle cache that we cannot use everywhere. That is going to be produced on your local device, and it will be used on your local device. You cannot share this one with the others in the team. One thing that we can share is Gradle build cache, and which is the output of the actual execution of the task. But when we have a problem, we don't want to go and restart Android Studio, because that is definitely not going to fix your cache issues about your compilations or your task execution. Android Studio lives in a higher level, and it's just there to help you to write the code. It doesn't have any responsibility to run your code or compile your code. It might configure the compiler. There might be a bug about this one, but again, cleaning the cache is probably 99% of the time is not going to fix your problem. And it will create unnecessary operations on your device. You probably need to go and get a coffee, which is fortunate in here because I usually don't like coffee, but coffee in Italy is much better than what we have in Germany. And yeah, it could be a good thing or bad thing where you live. But what we would like to have, avoiding unnecessary computation as much as possible. One other thing is cleaning your build output. Like I mentioned, if you already have Gradle cache, that means when you run the execution again, when you run the assemble build, assemble debug again, the output will come from the cache. So there won't be any new execution, and the Gradle will say that, hey, I already have the input for, like output for this input, so I don't need to compile anything again. And probably it will just do an unzipping or moving the file as a build output. So cleaning your project is not going to solve your cache problem. It might just cause more headaches while you're trying to solve an actual problem. If you want to force re-execution, you can use rerun. And if you like to verify that your problem is just about the cache, you can use no build cache command line attributes to be sure that your compiler is able to compile everything from source, but the problem is mostly coming from the cache or the incremental build. Now let's talk about the Gradle build cache itself, how they define it. And mostly from their definition is what we would like to do, reuse the outputs of other builds and avoid the expensive execution as much as possible for the same input. So for the same input, we would like to have the same output so we can avoid it. The things needs to be consistent. This is how you can enable it if you already didn't. Is there anyone who is not using Gradle cache here or don't know if they're using or not? I see a couple of hands. So what I can tell, I had friends who were constantly avoiding the Gradle cache or any kind of cache because thinking that it will create more problem than it solves. But it turns out from our metrics, they were spending more time to compile on your local device rather than writing an actual code. So they were thinking they're fixing one problem, but actually creating much smaller environment for them to efficiently work. Right after we proved them, hey, yeah, you're spending average 10 minutes to compile after every change you have, or something similar, they were also convinced that, hey, if I'm spending multiple hours a day, maybe I need to sit down and try to create a reproducible repo or try to fix the issue in the upstream and help the rest of the people in the community. And if you like to configure the Gradle cache, you can do it in the settings Gradle file. You can change the location of the Gradle cache, and if you like to share a persistent storage on your CI machine, and if you are fortunate enough to be able to mount a persistent storage to do your CIs or your environment, you can say that, hey, I would like you to put the cache in this specific folder, so rest of my CI builds will see the same. This is one and manual way to share your cache, but is there a better way? Yes, there is a better way, and there will be more benefits of sharing this one. One, you will compile less and just use the output. You will have more time to develop what you like to do. You will shine in your job and probably create more output than your peers if they are not enabling the Gradle cache, which I saw in the past. And you will have less context switching. Like I mentioned, if you have 2-3 minutes compile time, it's a time to get the coffee or watch a YouTube video. So when we get rid of those and just move them after we develop a feature, we can watch or do those kind of things with a smile on our face, thinking that we accomplished something. But one thing that really important is we will have less energy usage in general. So avoiding this one is not just about our time, but it's also about saving the energy and the resources that we have. Not everyone is fortunate enough to have latest computer or resources to develop, but also our time is limited. We don't have the whole time on the world to develop something. So we need to use our resources as much as we can. And benefit, there will be less money spent on the CI, there will be less need to hire or exponential growth in your team just because your team is slow to create output. First thing I always suggest is just look at what you can improve rather than increasing the problem with multiplying with multiple devices and multiple people. Because that's also one approach that I saw in the past without solving any build issues or any modularization issues or any cache issues. They just increased the team size for a project, and it got much, much slower than before because the half of the team tried to solve the other half of the team's compiled problem or local issues. And benefit, we will be more productive. But it's not always shiny or it's not always great. What we will see in the real life is we will see lots of cache misses, even in our local devices. Even if we press the compile, we execute the compile again on the same source over and over again, you might see that some of the execution, some of the tasks are going to be executed from the source. There won't be any up-to-date check, there won't be any cache usages, there won't be anything, but it's possible that you might configuring something on the configuration phase, which is causing Gradle to think, hey, input has changed, I need to do the compilation or task execution again. And which is not what we want. What we would like to have when we compile, which is already compiled, there shouldn't be any execution, and the compilation is to finish in seconds. If you enable configuration cache and I have a proper cache usage, second build actually finish under a second. And it just say, hey, it's successful, I don't need to do anything, and it's just a breeze. That's also true if someone else in your team or your CI already compiled this one. Then the Gradle will be able to tell, I don't need to do anything. You already have what you would like to have for this input. Well, let's say we have cache misses. What could be the reason for those cache misses? One thing is not having an input or output already defined in the Gradle task. If you're writing your own custom Gradle task, always consider to use a class-based Gradle task generation rather than using the Groovy or in-script Gradle task. Because when you use in-script version, there won't be any way to create a cacheable version of it. But if you create a class version of that task, you will be able to define what is your inputs and outputs. And why it's important, because when there is no input, Gradle will not have any way to understand if the output will be different or the same, because it really relies on the input. And when you don't have an output, let's say you're just printing something on the command line or executing a network request, which is not registered as the output, then Gradle will also think that, hey, with this input, I have no idea what's going to happen after this one. And probably when you investigate your build scripts or build pipelines, you will find lots of Gradle tasks like this. And it's a huge opportunity to improve, like a small change, just getting a Groovy script or like in-script Gradle task and converting it a proper definition with an input and output, you will be able to get some seconds from your build. Or the other topic would be non-deterministic input. If your inputs are depending on dynamic values at the configuration time, even if the outcome will be same, Gradle has to execute those. And we are not going to give the proper input information to Gradle if we keep dynamically changing non-deterministically. It's also the same for using the same input and output file or folder. Why? Because again, if our input is going to change after we execute a task, That means our task needs to execute it again because input has changed. So it creates a loop and circular dependency in the task management system as well, but it's also create a confusion. So when you write a task, always consider to have input definition and a separate output definition. Don't use same file. So the rule of thumb, when you execute something on the Gradle task, do not modify the same file as your input. Get it? Think as an immutable type, and create a new folder or create a new file outside of the input. And the other interesting thing is not properly declared inputs. And we have a long existing issue in Room library. Room library asks a string as a database schema dependency. Sorry, database schema path. And they use file and folder APIs in runtime to understand is there is a file if they need to change anything. But interesting enough, that string will stay same when you compile when you execute the compilation again and again. And let's say you deleted your databases. The string will be the same. There won't be any reason to execute data schema export. Or let's say you change the file of that schema, and when Gradle goes and checks the string, it will be the same. So how to fix this one? They actually need to ask for, hey, which file or which folder you want us to put in there as a proper file or folder declaration. And with that way, Gradle will be able to check if the file has changed or is the input has changed. But they still have an open issue. And if you have time, just go and vote for it and save lots of time from other developers. But the good thing is Gradle is flexible. Like I mentioned, there's a configuration phase. We can configure inputs and output. And most of the things, like I mentioned, no input or no output, can be somehow configured in the configuration time. We can even print the inputs and outputs of a task to understand what will be the difference. We can write wrappers or a task to execute before the problematic task to adjust their input so we can avoid having cache misses. One example could be that if a Gradle task is getting a list of files as an input, and if the order of that list is non-deterministic, it could happen. Those inputs might come as an outcome of the previous executions of other modules. And if one module is able to compile faster than either, it's possible that they might create a different order for the input. And that also existed in Android Gradle plugin for such a long time for the transpose dependencies. And luckily enough, they fixed this issue in the Android Gradle plugin 7 by just sorting the input at the configuration phase without relying on the execution time. And those kind of issues also can be fixed just by creating a wrapper yourself and configuring the input and output. But what we'd like to do is having our cache coming from the same place. We would like to have a single source for cache, so when we have an output, it will be easy for us to reproduce that output. We would like to have a consistent cache without any local change, because what I'm developing is not going to be interesting for anybody else, and I might try or execute lots of local execution, but it's not going to be useful for someone else in the team until I commit and open a PR or push a branch or merge something into develop. That's the time when they need to compile, not during the development. And if we have our CI as a source of truth for our cache, we will have less upload and the computation use on your local device, because if we are not going to produce our outcome for the remote server branch, we won't need to upload anything and we will just download. And one other benefit is running unit tests will be much faster, because the task has the proper input and output definition. So if the source is same, as a contract, your test will produce the same output. And then if a file or configuration is not changed in a module, Gradle is able to skip that execution and just only focus on change and affected modules. This dropped our average unit test time from almost 20 minutes to 3 minutes on CI. And that was like a huge win because we were able to get the verification much, much quicker. That also created an motivation for everyone to create smaller modules, because then they were able to do those kind of execution much faster on your local device rather than running all unit tests when you run the test locally or on the CI. But let's say we would like to share what we have on the CI. We have a branch, let's say master or other branches, and we would like to share this one. What we can use, if you're lucky enough and if you convinced your boss to include Gradle Enterprise to your budget for next year or this year, the Gradle Enterprise comes with a build cache server, which is managed by the Gradle Enterprise. But let's say you don't have it. What other options you have? Build cache server or like application is actually free to use. And then if you like to prefer to run a Java application, it's a Java application, you can directly run the jar while giving the configuration. If you like to have a Docker image on AWS or Google Cloud and just to manage this one with Kubernetes, it's also possible. They have a nice documentation with extensive examples, and you can probably find it easy to configure. But again, so much thing to do. I'm lazy, I don't want to do that one. But what I can do, I'm not a DevOps. I don't want to configure the server. I don't want to configure when it's going to run, which persistent storage it will have, which kind of security or SSL certificate it will have, or who will have access to reach it. What other option is what Google and Android X team is using? They created their own remote cache implementation plugin. So they would like to leverage their own infrastructure, which already comes with security, user management, and most like other kind of lifecycle improvements, rather than running a server on CI. Because running that server will also cost some money, and we also like to save that money and energy. Google Cloud Storage is fairly cheap, and this implementation basically does the similar thing what the Gradle's remote server implementation does, and just creates an HTTP connection, sends the input, and asks, is there an output for this input? Is there an output for this input? And try to get it from this bucket. And if you are able to, we are already able to configure how old we would like to have our caches, so we can also configure this one in the Google Cloud Storage. You can go and check it out at their repository, and I think they're using this one for such a long time, but it saves us to do all of the DevOps things. And if you like to just bring the benefits to your team, you can go ahead and use it. If you like to change the implementation, and I don't know, you like to use AWS S3 buckets, it's also fairly easy if you know what you do with this Amazon or Google SDKs to connect with those buckets. But the idea is same. What you have in your local device is going to be the same for the same input. We would like to get those output. And when we have a remote storage, which is a persistent, we can share those outputs within the builds. There will be less DevOps, less thing to configure, and only just focusing on what we can get benefit of. But is remote cache always better? This is also an interesting topic because we have interesting, really, really different task definition. Not everything is about compilation. There will be copy operations, there will be merge, packaging, and renaming. There will be different kind of operations. Like it's really, only limit is our imagination as a developer. Because I mentioned there will be configuration time, we can configure everything in a way we like, and there is no best way or right way or wrong way. There's only a way that is configured in your project, which is legacy, and you don't want to touch it, probably. And the question is, do you want to cache all of the Gradle task or not? And the answer is no. Not every Gradle task is all right for caching. Those are three examples that are binding merge, dependency artifact, bundle library class, and bundle library cluster. They're basically a copy operation on your local machine, and they are disk bounded. So doing this execution on your local device will be faster than downloading a dependency from network, unzipping it, and doing the copy operation from the cache to your build output. So there will be a copy operation. You cannot avoid it, but what you can avoid is like downloading and unzipping. And some of those bundle library classes in there might produce megabytes of outcome. And if we want to cache them, there will be a negative impact because Gradle will not know what to do with it, and it will always try to get it from the remote cache, but probably executing in your local device will be faster. Good thing that we have an open source library directly from Gradle, Android cache fix, and they aim to fix those kind of issues even before the upstream owner of that library or the task fix the issue. You can report your problems over there, and if it is possible to create a workaround, they will create a workaround with you and share with everyone else to avoid unnecessary compilation. And those issues already fixed in Android 7.2 Alpha 6, but not everyone is fortunate enough to use the latest version. But the good thing is if you use this plugin, they are able to fix those issues in the older version of Android Gradle plugin with the workarounds I mentioned before. They also have a workaround for the room library issue. And if you don't want to wait for Android or Google team to fix this issue because it might look a minor issue for them, rather than working on a new fancy, shiny feature, we can use this Gradle cache fix. And I highly suggest you should try and see if your build times is getting improved. And there will be a life cycle of remote cache, which I already mentioned, downloading, unzipping, and using. Why? Because we would like to zip the cache output, so there will be less bandwidth usage. And in any of those cases will be slower than what we can execute on your local device. And there's a way to learn this one. There's a Gradle Doctor plugin, which is also maintained from the similar people. And it is able to show that, hey, what was the execution time for this task before? And what is the download time and using the cache for this input? And it's able to print out the negative outcomes, negative gains for the remote cache to help you what you need to disable. And you might also find unnecessary executions or outcomes or outputs in your Gradle task that shouldn't be there. For example, if you're compiling a code, in the output, you don't expect to see resources or images. But let's say you compile a single file and there's like 100 megabytes of APK write after just compiling. It might be possible that that task is doing too many things, and you might want to split so you can start reusing your Gradle build cache as much as you can. And how much you can save. So hitting the 80%, 90% cache usage is like a sweet spot. When we start this journey of fixing our cache issues and making sure that we are using remote cache, our average usage was like 30% on our local devices. So for a really, really long time, even if it's not our own code, even if we didn't touch that module, developers had to do those execution and spend extra time for the topics they didn't touch. And when we start fixing those problems, incremental build times start going down and down. And there was a pinpoint that everyone was saying that, hey, our build times is good enough. And they stopped complaining. And it was like 3 years ago. We didn't have a mom machine yet. So it was a good excuse for everyone to be happy with the Intel devices. But we also know that with all of the metrics and capabilities, we created a benchmarking with the M1 machines and showed that, hey, this device will have much faster RAM, much faster SSDs, and the CPU is also much faster. So we created those comparisons and already showed that even in the cached version of the build, M1 machine was faster than the Intel one because of the different architecture and different reason. But that's a journey that we also need to see that if our build output is depending on our device. But how to go forward, what you can do. Disabling the cache could be only a temporary solution until you fix the problem, because in the long run, it's going to cause lots of headache, even without you notice. It might become your default. It might become a statico for you to wait 5 minutes for a build, but that's not the reality. There are projects and companies are able to build like 10 seconds, 15 seconds for the incremental changes, and you can have this kind of environment and work on your project happily. And if you have a reproducible case, please, I beg you to report it upstream so millions of other developers can benefit out of it. And you can spend 1 hour to find out the root cause, but imagine the amount of energy or amount of time you're going to save. And consider using the remote cache. You don't need to go and buy Gradle Enterprise or manage your server. You can also start with a persistent storage that you have, and you can even use a Raspberry with a hard drive on your local machine, on your desk, to verify that if it's going to work for you. So thank you, everyone. Thank you for coming and listening. And if you have questions, I'm here, and I will be around.
Thank you, Sinan. Thank you a lot for your talk. I think